Hi everybody. Today we are going to be taking a look at how we can use a sine function to write an equation of a tide. So it's summertime. I know a lot of us are going to the beach. We know there's high tides and low tides throughout the day. You can actually take a look at the graph of those high tides and low tides and see that it looks like a periodic function, just like a sine function. So I'm going to show you what that might look like. So here, this is the tide for Duck, North Carolina for today and tomorrow. You can see that this looks really similar to our sine and cosine function. So this is what we're going to use to, this data is what we're going to use to write an equation of these tides. So all of this data is down here, and you can see this is from usharbors.com. I'm going to be using the data from July 14th. I'm going to use the first high tide of the day, which it was at 2:39 a.m. and it was 2.6 feet high. And I'm going to use the first low tide of the day, which was at 8:46 a.m. at 0.5 feet. I'll use those two pieces of data to help me model an equation or model a tide with a sine function. So first, I'm going to write down that data. So we had a high tide, our first high tide, and that was at 2:39 a.m. and it was 2.6 feet. And then our first low tide, that was at 8:46 a.m. and that was 0.5 feet. So there's a bit of a glare here, so you can see that's that data that I just pulled out. So I'm just going to sketch a little graph of this. Before I do, I'm going to convert these minutes, the 39 minutes and the 46 minutes, into decimals. So we have 39 out of 60 minutes in an hour. That would give us about 0.65. So 2:39 a.m. is actually 2.65. So that's the number I'm going to use for that time. And the 46 minutes out of 60 minutes in an hour, that comes out to about 0.77. It's actually 0.76 repeating, so I'm going to use 0.77. So that time I'm going to express as 8.77. So a little sketch of this, if we have our time here as x and our height here as y, we have about 2.65 here, and it was 2.6 feet there, so that's our high tide. And then over here I have 8.77, and that's 0.5 feet, that's our low tide. So we go from this high tide to this low tide. So you can see that's actually sort of like a half of a sine curve, just from the high tide to the low tide. So this is half of a period. Remember, a period would go from a max to a max, or from a min to a min. That's one full period. So here we're using half of a period of data to model this sine function. So the first thing I'm actually going to do is assign my variables. I said x is going to be the time after midnight. So that's the time after midnight on July 14th. And then y is the height in feet of the tide. So we'll use those two variables here in my function. The next thing I want to do, as we've talked about in class, we know that a lot of these functions are sort of based off of this central line that sort of runs through our sine and cosine curves. We know our max and our min are sort of equidistant from that line. So I can average my max and min, here my height, and I can get that center line. So here this would be y equals 2.6 plus 0.5 divided by 2. And when I do out that arithmetic, I get 1.55. So we have 1.55. I'm going to write that off to the side. So let me erase this up here. I'm going to write that down. Y equals 1.55. I'm going to save that for later. Remember, in our parent function, that's normally the x-axis. So what that tells me is that I actually have a translation up 1.55 units. So that will help me with that piece of my function. Now the next thing I'm going to do is take a look at what this period is. So I can subtract 8.77 and 2.65, and that's half of a period. So then if I double it, that would be a whole period. So we have our period that's 8.77 minus 2.65. So that gives me 6.12. And so the full period is multiplied by 2. So if I take this 6.12 and I multiply it by 2, I get 12.24. So our period is 12.24. Another important piece of information I'm going to write down here. And one more piece of information I'm going to grab from this graph is our amplitude. So remember, the amplitude is how far up or how far down my curve goes from that center line. So one way I could do this is subtract 2.6 and 0.5 and divide by 2, or I can just take a look. I know this is 1.55, so I could do 2.6 minus 1.55, or I could do 1.55 minus 0.5. So when I do that, I get my amplitude. I'm going to call that A. I said I was going to do 2.6 minus 1.55. And so that gives me 1.05. So that's my amplitude. And I'm also going to use that for my function. So I'm going to keep this curve up here. I'll erase some of this extra stuff so we can get into writing this equation. So remember, our parent function, we'll have our amplitude, and then we'll have our sine function. We have this b value there, which tells us our frequency. Sorry, let me write this a little bit lower. I'll have my horizontal shift here, and then my vertical shift to end it. So we already know what my amplitude is. We know what this vertical shift is because we said that was 1.55. What I need to figure out now is my horizontal shift and then the b value, which is the frequency. So the b value is actually very easy to calculate. We know to get that b value, because we normally have 2 pi units in one full period of a sine curve, what I can do is then take that 2 pi and divide it by the period of this tide, which is 12.24. So you could keep it like that, 2 pi over 12.24, or you can reduce out a 2 and make it pi over 6.12. That's up to you. So that's how I got that B value. So we said that we had our vertical shift. Next, we need to get our horizontal shift. Remember, when we wrote our sine curves before, it starts sort of here at 0, 0, and we went up and down from there. So where I'm going to start, because this graph starts along that center axis, I'm going to start here along my center axis. So I need to figure out what the x coordinate is there, and that would be my horizontal shift. So this x value should be halfway in between these two times, the 8.77 and the 2.65. So I'm going to average those two to figure out what that coordinate is. We already know the y coordinate is 1.55. So if I just average those, 8.77 plus 2.65 divided by 2, that gives me 5.71. Okay, so that is my horizontal shift. So now I'm going to put all of this together in my function. One last thing I want to mention, I just erased my parent sine curve, but we have a positive A value out in front when my curve starts on my center axis and goes up from there. But what we have in my graph, it's starting at the center axis and going down. So that means I also have a reflection. So my A value here is actually going to be negative. So I'll have a negative in front as well. So let's put all of this together. We have y equals, we said, a negative A value. The A value is my amplitude, that's 1.05 times the sine. My B value is pi over 6.12. My horizontal shift is going to be to the right 5.71, so that's x minus 5.71. And then my vertical shift was up 1.55, so I have plus 1.55 on the end. So that's our very long function there. Now I mentioned I want to use this function to help me predict tides in upcoming days. So with that, I want you to take out your graphing calculator. I want to use this function here to help me predict when the first high tide is going to be on July 28th. So July 28th, let me erase some of this and I'll start fresh. I'll write my function up here. Okay, so there's my function. Okay, so x in this, remember, that's time after midnight on July 14th. So I'm still going to use this same function, but I need to remember that July 28th, that's 14 days after July 14th. So 14 days, which are 24 hours each, that gives me 336. So this is going to help me set my window when I'm plugging this into my graphing calculator. So my x min is going to be 336, and my x max, that's going to be 24 hours later than that. That's going to represent our July 28th, so that's 360. So this is my x min And this will be my X max in my window on my calculator. So make sure your calculator is in radians. We'll put that in. I'll adjust my window. And I graph it. So you can see here, my curve is up there. I want to use my calc function to find that max there. So when I find that max, it gives me the coordinate 345.37, 2.6, which we know it should be 2.6. 2.6 was the max. That was my high tide on July 14th. So it's also going to be the high tide on July 28th. Next, I want to convert this time into something that makes sense. So right now, that doesn't make sense to me as a time. I'm going to have to subtract 336 from that. So that gives me 9.37. And then I'll convert that 0.37 into minutes by multiplying that by 60. So when I multiply the 0.37 by 60, I get 9:22 a.m. So my high tide on July 28th should be about 9:22 a.m. Please let me know if you have any questions.